Okay, so we're going to get started. My name is Dave McCrory. I'm the CTO of Basho Technologies. We're a distributed database company focused on resilience, availability, and accessibility. My talk today is on data gravity and data agglomeration and the effects that this has on business and data. These are two topics that I've spoken about in the past, but not really together combined before. So first, I guess I should explain a little bit about data gravity. This is a term that I coined in 2010 that's gotten a lot of use over the past few years. And this is just a link to the blog article where I first described what I was noticing. So you have some data, and what I observed was as data was being interacted with, there were different properties that happened, especially in clouds and things. Generally, you had some source of data and you had some processing. Now, processing, I'm using in a very broad term. It could be actual transformation of data or use of data or something along those lines, or it could be an application that's either writing data or reading data and presenting it to a user. All of these things that are interacting with that source of data could fall under processing. So you have reads that occur. This could be an app, a service, a device. It could be anything that's a creator or consumer of data. And as these interactions occur, the data grows. Generally, you're not deleting data at the same rate at which you're creating data. I've seen cases where people do batchy things where they'll ingest a massive amount of data, do operations on it, and then delete it and start afresh. But generally, data accumulates over time. If it's not accumulating in a single spot, it's derivative data that's accumulating. So you're doing operations against data, you're pulling derived data or in-state transformed data out, and you're storing it somewhere. And that's really where you're getting the value, is in the information from processing that data. As this fans out and you have more devices or more apps or more services or other things that are interacting with this data, you end up finding that there are complexities with competing for these resources. There's a distance problem. Now, this could be a physical distance problem or a logical distance problem of how far away you are over a network or something like that. Time is distance, for those of you that have studied physics. And that really becomes latency when we talk about systems in the world of data. Now, if you have 200 milliseconds of latency and you're trying to do processing, and you have 50 milliseconds of latency and you're trying to do processing, one is advantaged over the other. The 50 millisecond processing is advantaged, and the reason is it takes less time to shuffle the data back and forth. Another interesting thing that derives out of this is commonly the closer you are to data, the greater the amount of bandwidth you also have. So not only can you move more data in a single go, but you can have more goes at the data. So this creates a gravitational effect of things being more advantaged by being closer to the data, so they are attracted to be closer to it because of that advantage. So you move from this to this, and you get a 4x advantage. You can do 4x the number of requests, and usually you have more bandwidth, especially if we're talking about greater distances. You have the speed of light problem, and that may determine specific behaviors of where you want to locate your data or where you might want to keep copies of your data. This is also what drives caching schemes and things like that because of the same effect. So keeping in mind that this is an attractive effect overall and that it helps guide where you want to do your processing. Do you do your processing with the data? If you have a large amount of data, then you move the processing to the data. If you have a small amount of data that you need to do a lot of processing with, then it might be more advantageous to move the data to the processing. Agglomeration is an oddly matched term to meet up with data gravity. Agglomeration's used in several different fields and industries. The one I have listed here from Wikipedia is economies of agglomeration. And this has to do with economies of scale and how agglomerative effects work with economics. There's also another agglomerative effect that's when you talk about particulates and things like that in manufacturing, where you want to combine smaller things and make them into bigger things, like say pellets or some other thing where you're sticking a bunch of things together to make bigger. So still an agglomeration, just not as specific. Agglomeration's an interesting topic because there's urban agglomeration. Urban agglomeration is the effect that you see in cities, and it's why cities form. So cities form because it's advantageous for people to end up working together and taking advantage of, over time, the economies of scale of doing things in a more efficient manner. So what I mean by that is if you look at the left-hand side, you will see this diffused network effect. If each of these was a supplier that needed to work with components, you can see it could be very complex if each of those pathways was separate and independent for you to build something. However, if you took and combined these and made them more efficient, and you had 3 primary pathways, say some very efficient highways even, and you had a skill set that was located in one area, and these were all, say, master craftsmen, and the other side were all people that did logging or something like that and got all of the wood. Efficiently doing all these things and having these separate skill sets combined in these locations becomes an advantage. This is a furniture store, so you'll also see like things end up being brought together, and I'll talk a little bit more about that. What I mean by like things are, in some cases, like stores can be combined. This is another agglomerative effect. In this case, it's furniture. In this case, you see agglomerative effects in types of products on aisles. So what you would not want in a store is for the electronics to be strewn all about the store in different areas. So there might be a television next to a bottle of milk that's next to a carton of eggs that's next to cleaning supplies. That would be very illogical, and it would also be very inefficient for you to go and find anything. And yet, this behavior exists in places where we do all of these odd things that are less efficient and have a much higher entropy. We also see this in selling cars. Cars is another interesting one in that the automotive side, whether it be here or anywhere else in the world, you see an agglomerative effect in that commonly cars are sold near one another. So lots of car sales near one another, and you'll see that the mechanics and things are also either part of the places where you're buying the cars, or they're in an area nearby, or all of the mechanics are located in the same general vicinity. This is because it's advantageous if you're looking, for example, to buy a car, for them to be closer to one another. If they were all strewn about, then the likelihood of you going to look at many of them would be lower. Their ability to have, say, salespeople that might move from one of these car sales companies, one of these car companies to another, would be less likely. It would be less efficient for them. So it's less efficient for the consumers looking to buy the goods and looking to, say, shop around. It's less efficient for the people that are trying to sell the cars. And it's less efficient if they're spread out for people to work on the cars. And the people that live by in these areas, it's easier if they're working for one of these companies and they wanted to move to another because their commute wouldn't change, for example. So things tend to cluster together because of this. That's an agglomerative effect. This effect is everywhere. People just don't necessarily realize it. So this is a set of temperature, barometric pressure, and other things that you would use as sensors and such for gathering weather data. These are data generators. So I look at any kind of sensor as something that generates data. I do this because as we look at IoT and all of these other things that are coming that are going to push even more data creation, it's going to become much more important that the world understand how agglomerative effects work, how data gravity works, and how to deal with the data in an efficient manner. And if you don't believe me with how these things work, I'd ask you to look at this. This is a map with weather data. It's taken from the Met, and you'll notice that, oddly, the weather stations that are listed here seem to clump up in these areas, and these areas seem to be where the cities are, where the people are. So this is a way of visualizing agglomeration from a set of data generators. And if you notice, where the cities are seem to be where the most sensors are. The same thing is going to exist all over. This is a pattern that happens over and over again. And understanding it's valuable not only for manufacturing or for systems design, but in understanding how the data needs to be related. So if I wasn't aware of geography and I looked at all of these weather sensors as the same, I would have no context to understand the patterns that exist. This is something that's important. It's also important to realize that there are places where there are no weather sensors. So if you look, there's a great big area here that above my hand that have very few sensors, if not any. And if you were looking to more accurately predict the weather, you would want more sensors. The more sensors you have, the more data you have to pick up on patterns, to do machine learning, to do prediction, to do all of these things. But it's much easier if there are already weather sensors there, and hence we have more in the denser areas. So you have these sensors, and they're storing data in a database. The database is interesting because we think of databases as one thing, and we think of them as a source. It's really an isolated island. And as a side note, this is the island of Luzon. It's interesting because the edge here is actually part of Luzon. This is actually an island inside of the island of Luzon. And then inside of that island is yet another island, Vulcan Point. So you have an island with a lake, inside of it an island with a lake, inside of it an island, and there's a lake inside of that too. It's interesting because all of them are isolated, and if you were inside that inner island, you might not have any idea that there's actually not only an island around you, but then yet another island on the other side. If you had no awareness of that, you would have no awareness or context on what you were really seeing around you. And the problem exists with databases. If you think about it, there are efficient ways to deal with data, and if you bring the data together, so if you have databases or data sources that are closer together, you can be more advantaged. The more diffused or disparate they are, the less advantaged you are. And this is one of the things that drives not only the cloud businesses, so if you think of AWS or Google or some of these, or Azure for that matter. If you think about these are agglomerative effects where they've created an ecosystem. This ecosystem that they've created becomes fortuitous in the fact that if I'm reliant on a data source that is in, say, AWS, then I'm much more likely to want to build my service in AWS because I'm going to get faster access. It's going to be easier. My data costs could be lower. There are all sorts of advantages for me to do that. So it ends up creating an attractive effect as well. So we have diffused and agglomerated data, and this data while agglomerated, it doesn't mean that it's all combined on the same database. It just means that it's all easily accessible in a way where I have the context that I need to get what I need to out of it, and that I can leverage the advantages of data gravity that I talked about earlier. So you have all of these sensors and such, and you have an application or a service that is driving access to these multiple data sources in the cloud. These data sources still have to be combined by that application or service for the data to be useful. If these data sources are in different clouds and they're far enough away, this becomes really slow and painful, and you end up having to either cache or copy the data, or you end up with slow or stale data, and you're not able to take advantage of agglomeration because of the disparate spread of data. This all matters if you're trying to deal with complex things, if you're dealing with ecosystems. So this I pulled off the web. These are all Google Cloud partners. So these are people that are trying to take advantage of the fact that people might be running on Google and using their system and using their ecosystem itself. This is an agglomeration. This is an agglomeration of companies that have been attracted to partner with Google and leverage their infrastructure, and to try and hopefully be attractive just as a city might be attractive to other newcomers or a startup, or there might be a district in a city that has a specialization. Maybe it's dealing with fabrics or something. So you end up having an area of a city that's dealing with fabrics, so all of the fabric merchants end up going and agglomerating into that area. They do that because then they are advantaged, and so are the customers. This is AWS for Big Data. This is, again, more agglomeration. These are different companies, but they've all landed on doing big data operations on Amazon because of what Amazon listed and provided out there as a set of services. So again, another attractive effect. Same thing for Azure. I just wanted to not make everyone think that I was favorable to any of these clouds. I'm really not. It's more of just trying to demonstrate the effects and what's there. So how does all of this then tie back to what you could do with your company or business? Well, there's several different aspects, not only looking at agglomeration and looking at data gravity, but there's what you do with the data and how you leverage it. These companies are oligopolies that are really, they're really in a position where they control the majority of the data between them. They're all credit-based companies where they're dealing with your credit information, history, and such. And they have an amazingly valuable business model. They have this value because they have taken all of the data and about you and me and everyone else, and they've created an arbitrary thing called a credit score. And that determines if you can buy things or not, if you can get a card that allows you to have credit. So they have direct control over this data. I'm not saying this is a good thing. I'm not saying it's a bad thing either, but I'm saying they created an ecosystem where they control this data, and they make a great deal of money very efficiently off of this. And most businesses, as we move with IoT, where we have all of these data generators, will have things that allow them to get data that can be advantaged in one way or another. So it's looking for how you can leverage agglomeration or create an agglomerative effect. If you can create an agglomerative effect like these companies did, you can increase the profitability of your business, you can increase the efficiency of your business, or you can even create new business lines based on this. But you have to look for it. AWS and Azure and Google are trying to do this with their ecosystems for clouds, and they're actually successfully doing it, I might point out. But it does cut across any type of industry. My favorite that I'll pick on, at least the one that's impressed me the most that I've had direct contact with, is the weather company. The weather company is interesting because, at least in America, they own the weather data. There is a public weather branch of the government, like the Met, but when it comes to actual level of information that's collected on weather and such, the weather company eclipses all of the others. They eclipse them because they've done things such as distribute home weather stations. So people can provide these, can get these weather stations, put them in their homes, and that data all gets sent to the weather company. Now you can do all sorts of things with your weather station at home, and it is yours and such. But that data gets collected by the weather company, and so does a lot of other data. Well, they took this and they've built many businesses out of it. They collected the data and then they created lines, for example, for the insurance industry. So for the insurance industry, if we're talking about automobiles, they have a product that they sell that to the insurance companies that will provide them information where if you're a driver and you have a smartphone and you're in an area where it's going to hail, they can alert you before it begins hailing to put your car into cover. They found that they were able to reduce claims by in excess of 25% by doing this. So there's a direct cost savings to providing that information and doing that association. They've also done a similar service with airplanes. So they provide a turbulence monitoring service. And that one's interesting because they require anyone that signs up to put sensors on their planes. So if you're British Airways and you want to access this service, you have to put sensors on your planes to send them turbulence data as part of the deal. And then you send them the data, but they give you information on where the turbulence is in advance. And so they are able to, by you using their service, they're able to get even more data. This is a virtuous cycle that's incredibly valuable to businesses. If you can find a cycle like that with customers or with your business or business model, this is something that is going to let you print money. It's an incredibly valuable way and approach. But these are the business models that I think are going to rule the future, are those where they're leveraging pure data. They are making part of the payment of you accessing their data, providing them data. This builds on that massive data and makes them even more valuable, and it makes them incredibly sticky and difficult for you to want to leave. This is really why I believe it's important to keep an eye on these things. It's something that my thinking continues to evolve as I learn more and I interact with more businesses and see what they do, different approaches that they're taking. But this is where the future of really any kind of business is going. It doesn't matter what your business is. It's more of finding a way to leverage these interactions so that you can maximize your profits and your efficiencies. With that, I'm going to end the talk. I have a few minutes before the session ends, so I'm happy to take questions if anyone has questions. Anyone? No? If not, I'll end the session. I appreciate it. Thank you.